Hello everyone, welcome to Homework Help. Please consider supporting the channel by becoming a member using the join button. In this video, we'll solve a related rates word problem. As per the problem, a dog runs across a bridge at a rate of 4 meters per second. The bridge is 5 meters above the water. A fish swims right underneath the dog at a rate of 3 meters per second in a direction perpendicular to the path of the dog. Find the rate of change of the distance between the two animals 1 second later. The first step is to draw a diagram for this problem to understand what's given and what we need to find. The diagram for this problem is a three-dimensional or 3D diagram. Let's start by showing the direction of motion of the dog. Let's assume the dog is running in this direction. The speed of the dog is 4 meters per second. The dog is on a bridge and the bridge is 5 meters above the water. A fish is swimming at a speed of 3 meters per second in a direction perpendicular to the path of the dog. Let's assume the fish is swimming in this direction at a speed of 3 meters per second. We have to find the distance between these two animals 1 second later. For that, we have to use variable t for time in seconds. We should find the distance these two animals move in t seconds. For that, we have to use the formula for distance. The formula for distance is speed times time. Let's start with the dog. The distance moved by the dog in t seconds will be equal to the speed of the dog, which is 4 meters per second, times time, which is t. So the distance moved by the dog in t seconds is 4t. Similarly, the distance moved by the fish in t seconds is 3t, because 3 is the speed of the fish. Now we can draw another diagram for this problem to show the distances traveled by these two animals. The dog traveled a distance of 4t and it is at a height of 5 meters above the fish, and the fish travels a distance 3t in t seconds. The unit of 4t and 3t is meters. We have to find the rate of change of the distance between the two animals 1 second later. The distance between these two animals t seconds later can be shown by this line. Let's assume the distance between them is x meters. Since we have to find the rate of change of the distance between the two animals, that means we have to find dx over dt at t equals 1 second. This is a very important concept we need to understand to solve this type of problem. As per the problem, the fish is moving in a direction that's perpendicular to the path of the dog, and the starting point of the dog is 5 meters above the starting point of the fish. In this diagram, the sides represented by 4t, 5 meter and 3t are perpendicular to each other, because the side that represents the direction of the motion of the dog is perpendicular to the side that represents the height of the bridge above water. Similarly, the side that represents the direction of motion of the fish is perpendicular to the side that represents the height of the bridge above the water. Therefore, the sides that represent the distance traveled by the dog, the fish, and the height of the bridge above the water are perpendicular to each other. There is a very important concept we need to understand and memorize. Therefore, we can use Pythagorean theorem for 3 dimensions to write an equation for x. The equation is x equals 4t square plus 5 square plus 3t square, all under the square root. This is a very important concept we need to understand to solve this type of problem. Now we can simplify the expression under the square root. Square of 4t is 16t square. 5 square is 25. Square of 3t is 9t square. Now we can combine the like terms. 16t square plus 9t square is 25t square. Next, we can simplify this expression by doing common factoring. We can factor out 25 from both terms. Square root of 25 is equal to 5. This is the equation for x. We have to find dx over dt, so we have to find the derivative of this equation with respect to t. For that, we should change the square root to rational exponent 1 over 2. Now we can find the derivative with respect to t. On the left side, the derivative of x with respect to t is dx over dt. On the right side, 5 is the coefficient of the term. It's a constant, so it will stay as it is. We should use chain rule to find the derivative of t squared plus 1 to the power half. The inner function is t squared plus 1. The outer function is the exponent half. As per chain rule, we start with the derivative of the outer function. We should use power rule. We move the exponent half to the front of the term and subtract 1 from half in the exponent times the derivative of the inner function t squared plus 1. The derivative of t squared with respect to t is 2t as per the power rule. 1 is a constant, so its derivative is equal to 0. Now we can simplify this equation. Five times half is 5 over 2. In the exponent, half minus 1 is negative half. 2t plus 0 is equal to 2t. We have to find the value of dx over dt at t equals 1 second. So we should sub in t as 1 in this equation. One squared plus 1 is equal to 2. 2 times 1 is 2. Next, we should move the term 2 with the exponent negative half to the denominator to make the exponent positive. Next, we can simplify this expression. We can cancel out the 2's. Exponent half is equivalent to square root, so we get square root of 2 in the denominator. We can rationalize this fraction by multiplying the numerator and the denominator by square root 2. I get 5 square root 2 over 2. This is the exact value of dx over dt, and the unit is meters per second, because the unit of x is meters and the unit of time is seconds. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.